Welcome to This Explainer. Now, if you're like most people, you probably picture the ancient sling as, well, kind of like an underdog's makeshift toy, right? But today, we're actually launching a formal forensic investigation into what is arguably one of history's most misunderstood weapons. We're going to strip away the myths, bypass all the folklore, and look directly at the cold, hard ballistics of a tool that literally shaped the borders of ancient empires. It's going to be fascinating. To really wrap our heads around what this weapon could do, we have to look at the historical record. Take the Book of Judges, chapter 20, verse 16. It states, "Everyone could sling stones at a hairbreadth and not miss." Now, sitting here today, it's super easy to just dismiss that as ancient hyperbole, but as the data is going to show us, this text objectively establishes the baseline for a class of elite, lethally accurate warriors. We're talking skills that absolutely rivaled modern marksmanship. So here is our roadmap for the explainer. First, we'll look at the ancient military weapon itself. Second, ballistic speed and energy. Third, the medical effects of impact. Fourth, elite accuracy and range. And finally, we'll wrap up with a forensic case study, the fall of Goliath. Let's get right into it. Section 1, the ancient military weapon, design and historical deployment. What is absolutely fascinating here is the sheer scale and standardization of this thing. We really need to completely dismantle this modern idea of the sling as some sort of child's toy. The ancient sling was a highly effective, incredibly dangerous piece of military hardware. It consisted of two leather or woven cords about 2.5 to 3 feet long, connected by a central leather pouch. So this wasn't just a makeshift hunting tool you'd throw together. It was standard issue for organized armies across Israel, Assyria, Egypt, Greece, and Rome. And it was engineered specifically to launch solid stones weighing anywhere from 50 to 150 grams. And the design of the weapon naturally dictated the specific ammunition they needed. 1 Samuel chapter 17, verse 40 tells us the combatant chose him 5 smooth stones out of the brook. Now, from a ballistic standpoint, that is a highly calculated move. Smooth, water-worn stones were deliberately selected by experienced slingers for a very good reason. Their clean, aerodynamic profile meant they flew significantly straighter and truer than rough, jagged rucks. This actually brilliantly illustrates how the core technology evolved over time. You see, later Greek and Roman armies actually upgraded from stone to cast lead bullets. Because lead is so much denser, this aerodynamic shift dramatically increased both the projectile's speed and its effective range. We've even found archaeological examples of these lead projectiles inscribed with messages like "take this," which proves ancient trash talk was very real and, honestly, very lethal. I mean, these weapons generated enough force to physically dent solid bronze armor. They were entirely capable of killing heavily armored men and even their horses right there on the battlefield. All right, moving on to Section 2, Ballistics, Speed, and Energy, the physics of a stone projectile. So, what kind of speed are we actually talking about here? Well, modern ballistic testing using reconstructed ancient slings has verified a staggering velocity of 100 miles per hour, that's 45 meters per second, for a 70 to 100 gram stone launched by a skilled slinger. And keep in mind, that's just the average for a professional. Testing shows that true expert slingers could push those velocities to over 120 miles per hour. That is literally faster than a major league fastball, but using a dense projectile the size of a golf ball or even larger. Now, when we compare the kinetic energy, a pretty terrifying picture emerges. A fast baseball carries roughly 130 to 150 joules of energy. A powerful air rifle, that's about 30 to 70 joules. But our ancient slingstone, traveling at 100 miles per hour, delivers anywhere between 80 and 150 joules. Now, you might be thinking, well, that's mathematically less than the 450 to 600 joules of a 9mm handgun. But the absolutely crucial point here is the delivery mechanism. The stone has a much larger surface area than a bullet. That means it doesn't just cleanly pierce the target. It transfers all of that energy instantly upon impact. The result? Tremendous, debilitating, blunt force trauma. Which brings us to Section 3, Medical Effects of Impact, Physiological Trauma, and Bone Fractures. Clinically speaking, a direct skull impact from one of these projectiles is just catastrophic. A strike to the frontal bone results in a depressed skull fracture, driving sharp bone fragments inward. This causes severe concussive trauma, brain bleeding, and immediate unconsciousness. Alternatively, if we're talking about a strike to the temple, which happens to be one of the thinnest parts of the human skull, it ruptures the middle meningeal artery. That causes rapid epidural bleeding, leading to complete physiological collapse within seconds. No way around it, it's a lethal blow. But it's also important to understand that the head wasn't the only viable target out there. Even if a slinger missed the skull, secondary target injuries were immediately disabling on the battlefield. A heavy stone to the chest will break ribs and collapse lungs. A strike to the shoulder fractures the collarbone, instantly disabling that arm. I mean, imagine taking a 100-mile-per-hour fastball to the ribs without a pad and replace the baseball with a solid rock. Hits to the extremities will cleanly shatter the radius or ulna in the arm, or totally obliterate the kneecap and tibia in the leg. Basically, a hit anywhere on the human body completely removes a combatant from the fight. And this precise physiological trauma is totally corroborated by the historical texts. 1 Samuel chapter 17, verse 49 literally states, "The stone sunk into his forehead." Now, from a modern medical perspective, this description is entirely plausible. Modern archaeological evidence, along with advanced ballistic experiments, clearly demonstrates that these heavy, high-velocity stones absolutely possessed the kinetic energy required to fracture the frontal bone and physically embed themselves directly into the skull cavity. Let's look at Section 4, Elite Accuracy and Range, the combat efficacy of professional slingers. You have to remember, these ancient slingers literally trained from childhood. They turned the sling into an intuitive extension of their own body. Because of this lifelong, highly specialized dedication, experienced military slingers could reliably strike a human-sized target at effective combat distances of 100 to 200 feet. That is 30 to 60 meters away. And at closer ranges, their accuracy on smaller targets was practically pinpoint. They essentially functioned as the ancient equivalent of specialized sniper units, engaging and devastating enemy lines long before standard infantry could ever even close the distance. All right, Section 5, The Fall of Goliath, a forensic case study. Let's apply all this data we've gathered. Let's impartially analyze the combatants' protective profiles here. On one side, you have extensive, heavy armor. We're talking a solid bronze helmet, a coat of mail, leg greaves, and a massive shield. It is a formidable, nearly impenetrable defensive setup. However, notice the crucial vulnerability. Virtually every military helmet of that era required the forehead and face to remain completely exposed, simply so the warrior could see and breathe. Against a weapon that only needs a few square inches to deliver lethal force, that necessary anatomical exposure is a fatal flaw. So, let's methodically walk through this decisive strike, step by step. Step 1 actually begins before the battle even starts, the deliberate selection of dense aerodynamic stones to ensure maximum velocity. Step 2 shifts to the battlefield, the expert exploitation of that singular exposed forehead target. Then comes Step 3, the high-velocity impact delivering well over 100 joules of energy, causing a catastrophic blunt force skull fracture. This leads instantly into Step 4, immediate physiological collapse and loss of consciousness. And finally, Step 5, the subsequent beheading to officially confirm the death. Medically and ballistically speaking, a single, well-placed stone ending a heavily armored duel is an entirely plausible, scientifically sound sequence of events. And 1 Samuel chapter 17, verse 51 records this exact final action. It says, "David ran and stood upon the Philistine, and took his sword, and slew him, and cut off his head therewith." This effectively concludes our clinical breakdown of the engagement. The slinger incapacitated the armored warrior at range with overwhelming kinetic energy, and then closed the distance to confirm the lethal strike using the enemy's own weapon. Which leads us to a final, pretty compelling question to leave you with today. When we objectively examine the devastating speed, the immense kinetic energy, and the severe medical trauma generated by the ancient sling, must we completely reclassify this humble shepherd's tool as a highly sophisticated, incredibly lethal piece of ancient military technology? It really fundamentally changes how we view ancient warfare and proves that sometimes the most unassuming tools hide the most devastating scientific principles. Thanks so much for joining me for this explainer, and I hope this helps you clearly visualize the fascinating truth behind the history.